Introduction to Python Variable Arguments. Make your functions more flexible. Hello everyone. Today, we're going to learn about a very practical feature in Python variable arguments. This feature allows us to make our functions more flexible, enabling them to handle a variable number of arguments and significantly enhancing the reusability of our code. In today's session, I'll guide you through understanding what variable arguments are, how to use them, and their application scenarios. We'll cover the following sections: the concept of variable arguments, asterisk arguments, collecting positional arguments, double asterisk keyword arguments, collecting keyword arguments, using both asterisk arguments and double asterisk keyword arguments together, advantages and considerations of variable arguments, practical tips and application scenarios. By the end of today's session, I hope you'll master this feature and apply it to your own programming project. 1. The concept of variable arguments. First, let's understand what variable arguments are. In Python, the number of arguments a function accepts is usually fixed. For example, a function defined as definite func, a, b, c, can only accept 3 arguments. However, in some cases, we may need to handle a variable number of arguments, such as calculating the sum of an arbitrary number of values, handling uncertain user inputs, dynamically combining database query conditions. To address this need, Python provides 2 ways to implement variable arguments. Asterisk arguments, used to collect positional arguments. Double asterisk keyword arguments, used to collect keyword arguments. Next, we'll introduce these 2 methods separately and explain how to use them with examples. 2. Asterisk arguments, collecting positional arguments. Definition and example. Let's start with the first method, asterisk arguments. Asterisk arguments is a special syntax in Python that collects all the positional arguments passed to a function into a tuple. Here's an example. Key points. The key points of this code are: the function definition uses asterisk arguments, which means the function can accept any number of positional arguments. All the passed arguments are automatically packed into a tuple and stored in arguments. We use a for loop to iterate through the tuple, summing up each value, and finally return the result. From the 2 examples of calling the function, regardless of whether the number of numbers to sum is 3 or 4, the sum_values function itself doesn't need to be modified, just pass the arguments in. Application scenarios. This method is particularly suitable for the following scenarios: calculating the sum of an arbitrary number of values, such as grades, product prices, etc. Handling an uncertain number of input data, such as a list of numbers entered by a user. 3. Double asterisk keyword arguments, collecting keyword arguments. Next, let's look at the second method, double asterisk keyword arguments. Double asterisk keyword arguments is another special syntax that collects all the keyword arguments passed to a function into a dictionary. Here's an example. Key points. The key points of this code are: the function definition uses double asterisk keyword underscore arguments, which means the function can accept any number of keyword arguments. All the passed keyword arguments are automatically packed into a dictionary and stored in keyword underscore arguments. We use the .items method to iterate through the dictionary's key value pairs and print them out. When using this function, if additional user information is provided, such as residence or occupation, we only need to include these fields in the keyword arguments. Application scenarios. This method is particularly suitable for the following scenarios: handling uncertain configuration options, such as optional parameters for a function. Flexibly processing user data, such as dynamic fields in form inputs. Dynamically combining database query conditions, such as multi-condition filtering. 4. using both asterisk arguments and double asterisk keyword arguments. Sometimes, we may need to handle both positional arguments and keyword arguments simultaneously. In such cases, we can use both asterisk arguments and double asterisk keyword arguments together. Let's look at an example. Key points. Asterisk arguments collects all positional arguments into a tuple, while double asterisk keyword arguments collects all keyword arguments into a dictionary. Order matters. Asterisk arguments must come before double asterisk keyword arguments in the function definition. Basic output of the function. The first print statement outputs the entire arguments tuple. The second print statement outputs the keyword underscore arguments dictionary, showing the complete structure. Advanced item-by-item processing. Use the enumerate function to retrieve both the index and value simultaneously. Positional arguments can be accessed directly using value. Keyword arguments require accessing the corresponding value using key. Execution result. When running the above code, we'll see the following output. Positional arguments 1, 2, 3. Keyword arguments name, Xiaoming, age, 25. Positional argument 1, 1. Positional argument 2, 2. Positional argument 3, 3. Keyword argument 1, name, Xiaoming. Keyword argument 2, age, 25. Application scenarios. API wrapper functions, handling multiple input parameters and forwarding them to other functions. When developing APIs, we often need to handle various input parameters. Using variable arguments allows our functions to be more flexible, accepting different numbers and types of parameters. For example, when designing an API for querying data, we may need to accept multiple query conditions, such as filtering, sorting, and pagination. By using asterisk arguments and double asterisk keyword arguments, we can collect these parameters and forward them to the underlying query function. This not only simplifies the function definition but also improves code readability and maintainability. General data processing functions, suitable for handling structured or unstructured data. During data processing, we often need to handle structured or unstructured data. Functions with variable arguments can flexibly accept data in different formats. For example, when processing a set of user data, there may be different fields and attributes. Using double asterisk keyword arguments, we can easily pass this data as key value pairs to the function and perform corresponding operations internally, such as data cleaning, transformation, or analysis. This design allows the function to adapt to different data structures and eliminates the need to modify the function definition for future expansions. Core features of frameworks, for example, route handling functions in Django or Flask. In many web frameworks, such as Django or Flask, route handling functions often need to accept various parameters to process user requests. These parameters may include variables in the URL path, query string parameters, and form submission data. Using variable arguments allows these route handling functions to be more flexible, easily receiving and processing different request parameters. For example, in Flask, we can define a route handling function that uses double asterisk keyword arguments to receive all query parameters and then execute the corresponding business logic based on these parameters. This design not only improves code reusability but also makes route handling more concise and clear. 5. Advantages and considerations of variable arguments. Advantages. Flexibility. Variable arguments allow functions to accept any number of arguments, enabling them to adapt to different use cases, whether handling a small or large amount of input data. Simplicity. By using variable arguments, we can avoid listing too many parameters in the function definition. This not only makes the function definition more concise but also improves readability. Scalability. When new parameters need to be added, Functions with variable arguments don't require modifications to the original function definition, making it easy to expand the function's capabilities to meet future needs. Generality. Variable arguments are particularly suitable for use as proxy functions or decorators, as they can flexibly handle different types of parameters, thereby improving code reusability and generality. Considerations. Parameter order. When defining a function, you must follow the parameter order rules. Asterisk arguments must come before double asterisk keyword arguments to correctly parse the parsed arguments. Type checking. While variable arguments provide flexibility, in some cases, it's necessary to perform type checking on the parameters to ensure the function can correctly handle the input data and avoid potential errors. Documentation. To improve the usability of the function, you should clearly describe the types of acceptable parameters and their purposes. This helps users better understand how to correctly use the function. Appropriate usage. While variable arguments provide great flexibility, overusing them can make the code difficult to maintain. Therefore, use them cautiously to ensure code clarity and readability. 6. Practical tips and application scenarios. Tips. Asterisk arguments is a tuple. You can access its elements by index, but it cannot be modified. Double asterisk keyword arguments is a dictionary. You can access and modify its elements using key-value pairs. Type hints. Use type annotations to improve code readability. Application scenarios. Data processing. In data analysis and processing, variable arguments can be used to calculate various statistical metrics, such as sums, averages, and standard deviations. This allows functions to flexibly accept different numbers of data points for corresponding calculations, enhancing code generality and reusability. Dynamic configuration. When dealing with uncertain parameter combinations, variable arguments provide great convenience. This is particularly useful in applications such as configuration settings or options, where developers can flexibly pass different parameters based on actual needs without predefining all possible options. Framework design. When designing frameworks, such as web frameworks or libraries, variable arguments can be used to create general-purpose functions, API wrappers, and decorators. This design not only enhances code flexibility but also simplifies function calls, making it easier for developers to extend and maintain the framework's features. What problems do you most often solve using variable arguments? Feel free to share your experiences and insights.